So we've kind of talked about lines a little bit before, but now we're really going to get into slope and graphing. So what I always like doing is showing you guys, let me sign into here first. There we go. An easy way for you guys to remember slope, if you guys haven't done lines before, is slope is this idea of the rate of change. And the way we measure that is the change in y over the change in x. And the easiest way to kind of think of that is rise over run. And when we're dealing with lines, this is the m part of the formula. So if you guys aren't familiar with this formula, we will talk about it a little bit more. But in this, we're just going to learn about slope and lines and all that other weird stuff. All right. So finding the slope. So when we're finding the slope of a line, what we're looking at is what I like to do is I like to kind of go where it crosses the grid. So where it crosses these little points, I like to find 2 points where it crosses. So in this line, I see these 2 points. So when I'm trying to figure out my rise over my run, I'm going to go here and I'm like, oh, cool, my rise, I'm going down 2, and I'm going to run 1, 2, 3, 4, 5, 6, 7, 8. Is that 8? 1, 2, 3. Yep. So I have -2 over 8. So my rise for this, oh, we're just covering, I'm going way too into detail, guys. I'm sorry. So which one has a negative slope? Line B has a negative slope because it's going down and over. So line B, negative slope. Which one has a positive slope? That would be line A. Line A is the only one going up and over, up and over. All right. So like I said before, it's the vertical change over the horizontal change. That's our slope. Rise over run. Always remember that. So what's happening here, they're measuring, it's going up 8 and it's running 12. So find the slope. Finding the slope in algebra, again, rise over run. If it's going up, it's positive. If it's going down, it's negative. So if we're trying to find this slope, what we're doing here is we're counting. We're going down 4, so we consider it -4, and we're going to the right, +2. If we were going to the left, we would call it negative. But here's the interesting part. If we went to the left, we would have a negative over a negative, and that looks like a positive slope. So that's why that negative and the negative make a positive, is because it's going to end up doing the same thing as a positive thing. This one, we have a negative over a positive. Or if we went the other way, let's say I was like, oh, I'm going to go over this way, which is -2, but I go up 4, I would still get the same answer. I would still get -2 and -2. So my slope here is going to end up being -2, not even depending on which way I go. So usually you measure you go from left to right, but you can go right to left. Just remember you're putting your signs different. So like I said before, if I was going right to left, it would be negative, but I would be going up 4. So it'd be positive. Vertical change. So they're going to show us how to do it by the formula. I've never liked the formula because to me it feels very complicated. It's y2 minus y1 over x2 minus x1. And like I said, this is symbolized by m when we start doing the equation for a line. So what they did here was this is my y2. And over here, this is my y1, which you can see right here. So that's why they're doing a double negative. They're subtracting a -3. And then over here, this would end up being my x2. And this one over here is my x1. So again, that's why it's a double negative, because it's a subtracting -1. So that's how they get this 2/3. What I usually do is when I have them right next to each other, like let's say I have -3 comma -3, and then I have a 3 comma -1, I ask myself, how much did I run? I ran +6. How much did I go over? Well, if I'm starting at -3 and I go all the way to -1, I go over 1, 2. So I went up +2. So that's why I get this 2/6. So there's a bunch of ways to do slope. It's just whichever way you like to do it. And there's that complicated formula I told you. You can do it. I still use it. I'm just like, well, if I have the 2 points right next to each other, I can calculate it without having to do it. And notice how when you reduce it, it says 1/3. Well, if I go up 1/3, I'm still on the line. They just chose this point. So even if you choose a point on the line further away, it doesn't matter. You'll still end up with the right answer. Because even though they picked these 2 points that are far away, even though this one would have been a lot easier, they still got the same answer. You just had to reduce it. Is this making sense to everybody? I just saw Jasmine's comment on the no comment for camera. All right, so types of slopes. So we have negative slopes, we have positive slopes. This is known as a zero slope. The reason why it's zero is it doesn't have any rise. It doesn't go up. This one is all up and down, no run. So this is what's known as undefined. And the reason why it's undefined is, remember, when we're always doing our functions, we're always doing it in respect to y. Y equals something. But in this case, we can't say y equals something because it equals all of the y's. So our undefineds are usually like x equals 4. This is all the points where x equals 4. So that's why it's undefined. Whenever, that should be a 4, not a y. Whenever we define a function, we're defining it in terms of y. So in case you guys ever heard the term undefined and you never understood why it's called undefined, you cannot define this. It's every single y point, but it's only the point 4. So this, for example, is 4, 0, 4, 1, 4, 2, 4, -1, 4, -2, 4, 4, 1.5. It's all the points of y. So that's why it's undefined, is you can't really pick a point of y. It's all of them. This one is only some points of y. It's like y equals, I don't know, 3x plus, should be -2. This isn't the right formula. I just made one up. It's like, it's only the y values that follow this rule. This is every y value where x equals 4. So that's why it's undefined. You can't define it in terms of y. So when we're doing this, what is the correct slope of this? So when we're going from, I always do my y's first. I know you want to do your x's first, but remember it's rise over run. So I always try to do my y's first. So if I'm going from here to here, 5 to 2, I went down. It's a smaller number, so I went down 3. And if I go from here to here at negative 2 to 2, I went up. Or I should say, I went to the right. So that was at negative 2, negative 1, 0. So I went to the right. Let me do it in another color. I went to the right 2. So in other words, my answer ends up being negative 3 positive over positive 2. So that's the same thing as saying negative 3 halves. And that's why we get that negative 3 halves. They even show it right here. If you want to use the equation, go for it. Probably would have been a little bit easier, but in my mind, I'm already doing that. I'm already taking this 5 and taking away the 2. Asking yourself, how far is 2 away from 5 is the same thing as what's 5 take away 2? All right, and then this is known as our y-intercept. So remember I showed you guys this equation, y equals mx plus b? Well, this shows us what we're going to be multiplying x by. But this b shows us where we start off. So one thing, I found this online, I forgot where I saw it, but somewhere I saw that this is how we move on the x-axis, how we're going rise over run, and this is where we begin. So we begin right here, and we always begin where x equals 0. So our y-intercept is where x equals 0. So it's our beginning. That's how we begin a function. So let's take this and practice it. So we have this weird equation. This doesn't help us out. This is called standard form. This would be as if I'm like going clothes. That'd be really cheap clothes, but all right. This would be if I was going clothes shopping and X were my shirts and Y was, I don't know, socks. Like as it is, it's already too cheap. So this is saying that I'm buying 3 shirts and 4 socks, and I'm only spending $20. So that's how standard form is usually used. This represents the number of shirts, but the coefficient represents the dollar amount. So the numbers are representing the dollars, the X and Y's are representing a number. I don't know. I don't know how many socks I bought. But let's say, so what we would do is we would solve it the way we've been solving it. That's why I skipped through it really fast. It's like, oh, I want to get my Y by itself. So now I have my Y by itself. So now I know my slope. So let's say I want to figure out how many socks I buy. Well, if I want to figure out how many socks, I have to say every time I buy a sock, I have to multiply. Oh, X with shirts. Every time I buy a shirt, I buy less socks. That's why it's a negative slope. And which makes sense because if you think about it, if I buy no socks, I can buy more shirts. But the more shirts, the less shirts I buy, the more socks I can buy, basically. I know that's a little confusing, but that's what would happen in this case. That's why there's a negative slope. Every time you buy a shirt, you can only buy less socks. And as always, you guys can watch the video. I don't want to get too far into that. So let's get into this. So, well, we'll just look at this work for you guys. So that way you guys can see how to do it. So when you're doing this, you want to get your x by itself, so you subtract x from both sides. I hate how Edmentum does it like this, where it does it all in one line. I like more lines. So you subtract it, then you divide. So this is your slope, and this is your intercept. So again, just rewrite it. So our slope is negative 1/6. Our y-intercept is 6 because that's our coefficient. That's our constant. Since b is by itself, it's called a constant. So that's how we do those. Now let's graph a line. So graphing a line, we have to have it in y-intercept form first. That way we know where we begin and we know how to move. So when we graph it, we're going to start at 5. X equals 0, y equals 5. So it's our intercept. And then we're going to start moving. So we're going to go down 3 over 4. We have these 2 points. Make a line. That's all it is to make a line. So lines are when stuff has a constant rate. So for example, if you have limited minutes, every time you go over your minutes, you get charged a constant rate. Every minute is worth so much. So this one, we basically have everything done. We just have to divide by 2. So when we divide by 2, divide everything by 2, we get y equals negative 2x plus 3. And what this negative 2 is, it's really a fraction. You guys just don't see it. Negative 2 over 1. That's where this over 1 rule comes from. So what we're doing here is we're going to start off, our beginning is 3. So we start off at 3. And then our rise is negative 2. So we go down 1, 2. And our run is 1. So we go over 1, put our points, and we get our line. And if you guys want to see it, the way they do it, same thing. Starting point, other point. And then here they're just showing how we divided it out, how we got our coefficients. This part doesn't really matter. It's literally just them going down 2 over 1. But it's just a way they can say in words what they did. All right, and then let's see here. So this is slope intercept form. So let's say they give you a point. They're like, we have this point and we know what the slope is. You can use this point, but I don't like using it. And I'll show you why after I show you how to solve this. It's on the test, so you guys do have to have this not necessarily memorized, but written in your notes somewhere when you're taking the test. So when you're doing this, they're just going to convert it. They're just going to plug in the point. So they're like, oh, okay, so we have this point right here. They just plug it in here. So our 2 is our y. So we're going to plug it into y1. This y right here, is just a general y. And the x is just a general x. They don't really do anything. They're just there. So when you finish solving the equation, you can see it. So they subtracted out. They moved it. They didn't really show the work here. I don't know why they didn't show the work of them solving it, but they would distribute and then add. But instead of doing that, they're like, we'll just leave it like this. So if I did want to show it, the reason why I don't like this form is you can always solve for b yourself. So what you can do here is you can do what they did, which is like, plot the point and then follow the slope. So if we started here, we go up 1 over 3. But let's say they ask you for the equation, you would have to distribute, right? And then find your equation after that. So what you can do there is plug it in, solve for it. Or what I like doing is, they gave me a point. Cool. So this is my y. So I'm going to use y equals mx plus b and do the exact same thing. So y equals 2, m, I'm going to put 1/3, and my x is negative 1, and I need to solve for my b. So this is 2 equals negative 1/3 plus b. We bring it over. So we get 2 and 1/3. Luckily, there wasn't anything complicated. Our b is just 2 and 1/3, which if we look at our graph, 1, 1, 2, and a third. So either way you want to graph is fine. That's just how one of your options. So this is standard form. Oh, and they're doing the example I kind of did, but they're doing it with books, paperback books, and hardcover. So X is going to be our hardcover, or paperback, sorry. So X is paperback books. So X equals number of paperback books. Y equals hardcover books. Number of hardcover books. And they're spending $27. They have no idea how many books they bought. So they're like, oh, well, how many hardcover books did we buy? So what we do is they're going to plug in 0 for y and they get a y-intercept. So I don't know why they're doing it this way. When they have standard equations, what they like doing is they're like, let's solve for where it crosses the x-axis. Let's solve for where it crosses the y-axis. So the maximum number of books they could buy for paperback is 18. So they can buy, this is y. So since x equals 18, if we have none, X is how many paperback books we can buy if we don't buy any hardcover. Well, how many hardcover books can we buy? Let's find out. So if you plug in 0, the maximum number of hardcover books they can buy is 9. So if you're buying a combination of both, X is going to have to be less than that. And we're going to talk about inequalities later. I'm getting ahead of myself. I'm sorry. But that's how they solve this. They figure out the intercepts. So this is a good way to solve for intercept when you're graphing. I don't like how they keep teaching you different ways to do it, but they're giving you options. So let's use that intercept method. So what's our x-intercept? Well, our x-intercept, just remember the x-intercept is when y equals 0. And the y-intercept when x equals 0. Does this make sense why it's like that, or is it just going to be like a rule you guys memorize? Do you guys get it, or do you want me to go over why it's where the other one equals 0? Yes, no, maybe. Is it that x equals 6? Oh, it's supposed to be 0. I'm sorry. Thank you for pointing that out. I was like, what do you mean x equals 6? It's x equals 0. I'll just kind of go over it. The reason is, so let's say we're looking for the y-intercept. We're looking for this point right here, where it crosses the y-axis. So if we look at our x value, it's 0. If we're talking about this point right here, we're talking where the y value is 0. So that's how come it's always the opposite. So if I'm plugging in for the x-intercept, I want to basically pretend this isn't here. Why? Because 12 times 0 is 0. So this means that my x-intercept is 24. Let's say I'm solving for my y-intercept. That means I have to pretend that there is no x value. I have to pretend that x equals 0. So 10 times 0 is 0. So in other words, 24 divided by 12 is 2. And I have an extra 0, so that's 20. Does everyone understand how I got these numbers? These 24 and 20? Maybe somebody. Do you guys understand how I got these numbers? Okay, cool. Thank you. I was like, everybody there? So the next step is to figure out our rise over run. Well, if I'm looking at this, if I'm going from 0 to 20, my rise is 20. But if I look at the other one, I'm going down 24. So first thing I want to do is I'm like, well, I know I can divide these by 2. Oh, I can still divide these by 2 again, so I probably should have divided by 4 instead of dividing by 2, but oh well. So I divide this by 2 again. So I'm going to get this negative 5 divided by 6. So let's see how Edmentum does it, because if I'm thinking this, I'm thinking I want to put it like that. Remember, division and fractions are the same thing. So let's see how Edmentum wants it. Nope, they want it the exact same way, so we're good. And you can use the formula, but like I said, if they're already lined up nicely like this, it's easy to just kind of see how it changes. And if we want to graph it, well, luckily they gave it to us in standard form, so we just plug in 24 for our y. I mean 20, sorry. I got these backwards. Y-intercept is 20, so go to 0, 20. How do we do the x-intercept? We go to 24, and we're not going to go up at all. It's at 0. So now if we want to do this in point slope form, how are we going to do that? Well, we know that we have a few points here that we can plug in. So this is saying, what possible combination can we use considering these? 5 groups for every student. One possible combination. So we have 2 points that they're giving us. They're giving us this point and this point. So if they want groups to be the x value, groups are our x. So we have 18, comma 10, and another combination is 5, comma 12. So one thing we can do is we can use this as our point. And we already have our slope. But even if you did that, you could find your slope. You're going to go up 2, you're going to go over negatives 12, 13. Anyways, so what we're going to do here is we're going to see how we can do this. So we can do it as y minus 12. So none of them have y minus 12. Or we can do y minus 10. Am I doing these right? Student groups 12 minus 5. Do I have these backwards? That's an x. I have no idea what they did here. I feel like they did this backwards. Considering the answers from parts A and B, which of the following is the situation for this? So they want us to go up here? Minus. I don't know why they're using this one and this one. Oh! They're. This is what happens when I don't read. That's my x and my y. So that's why it's. So my point was 5, comma 18. Or, 18, comma 5. I'm so sorry, guys. I didn't read this. So I was like, oh, they gave us 2 points, but they're talking about groups of 10 and groups of 12. So that's why this is the only possible one. I was like, none of these are right, but our point is 18 and 5. And then you just plug in the slope. So if you guys want, again, well, not want. When you do your evaluation, you can write what you do. I would probably give myself like a 4 and be like, I didn't read it, so too many numbers. That confused me. Let's go delete this. All right, and then our summary. So here's our formula for slope. And there's 3 equations for a line. You can have it as y equals mx plus b, our change in x, plus our beginning. So like if you're saving money, you always start off at a certain point. I think we did this for one of them. She saves money, and then every week she puts in more money. That's that form. This form is if you're like, well, we know what the rate of change is. Like, for example, it's like, hey, we need to figure out how much money we're spending. It's like, oh, well, so far we already have like $10 in minutes. And I know it's like, I don't know, a dollar for every 10 minutes. So that's our rate of change. So we don't know how many minutes we use, but our bill already started off at $10. And then every additional minute it's going to go up. So it's not going to be that big of a slope because we're going to go up 1 over every 10. So that's another way of doing this. And standard form is that t-shirt and sock example I gave, where every time you buy more socks, it's going to go down. So that's another way, another form of lines. And that's pretty much it. Oh, I just realized I did not do question of the day. Um, I guess let me open up a file because I need to do. Yes, and you guys can answer it live or you guys can type it in. I'm not gonna force you guys to talk again since a lot of you guys were shy. But if you guys do want to chat, you guys can do that. Let me stop the recording. Oops, not that one.